Hello everyone, I am Dr. Swapna, working as a scientist in National Remote Sensing Center of ISRO, Hyderabad, India. I am going to present on diurnal variability of INSAT-3D SST in the Indian Ocean region, intercomparison with in-situ and satellite observations. These are my co-authors from National Remote Sensing Center. As we all know that sea surface temperature is an essential climate variable which is used in climate studies such as air-sea interaction, ocean mixing, boundary layer process and many more. To study these, we need high temporal resolution SST, which is provided from the Indian geostationary satellite INSAT-3D imager. It is providing 30-minute interval SST. So we have validated this SST in comparison with buoys and contemporary MODIS observations, and we have also attempted to study the diurnal variability of this INSAT-3D SST in comparison with buoy SST. The study area we consider is shown in this figure. Here the red stars denote the buoy locations we considered. Around 15 buoy locations were considered. So INSAT-3D SST data is taken from the MOSDAQ site of ISRO, and in-situ observations are taken from Indian Moored Buoy Network and NASA standard level 4 km SST product has been taken from the NASA site, and we have considered here the latest version of INSAT-3D SST. Previous version of INSAT-3D SST developed using the split window technique, which is a nonlinear SST algorithm, whereas the latest version of this INSAT-3D SST generated using the 1D variational technique. Here, coming to the results, the left top figure shows the scatter plot between the collocated buoy observations in comparison with the INSAT-3D SST. So we have got a very strong correlation of 0.8 with a RMSE of 0.54 and a bias of -0.2 degrees centigrade. And as we all know that SST has day-night variation also. So day and night validation with respect to the buoys has been carried out. We found very good correlation for the day compared to the night SST observations. And as we all know that the regional wise also SST varies, we have carried out the regional variation validation for the Arabian Sea and Bay of Bengal. We have got very good number of points for the Bay of Bengal and found a strong correlation in the Bay of Bengal compared to the Arabian Sea. And as we all know that satellite SSTs are skin SST, that is INSAT-3D here will be the skin SST, whereas the buoy SSTs will be bulk SST. The skin and bulk SST difference over the Arabian Sea and Bay Bengal also been studied here. So we found that around 53% of INSAT-3D SST is underestimated in the Arabian Sea, whereas 50% of INSAT-3D SST is underestimated in the Bay of Bengal. And coming to the diurnal variability study, these are the typical diurnal variability at buoy locations 1 and 10, which are shown in the figure 1. So the INSAT-3D and buoy SSTs are following the similar trend and with a difference of 0.2 to 0.1 degree centigrade, and the peak diurnal peak SST peak is occurring in the afternoon around 2:30 p.m. for this Arabian Sea and Bay of Bengal buoy locations. And here the diurnal variability, the histograms are shown for the Arabian Sea and Bay of Bengal in comparison with the buoys. For the left histogram shows for the Arabian Sea and the right histograms are for the Bay of Bengal. In buoys have shown less diurnal SST magnitude in comparison with the INSAT-3D SST. In the Arabian Sea we have found 0.02 is the diurnal SST magnitude, whereas for the INSAT-3D SST maximum number of pixels were showing 0.2 and again 1.2 for INSAT-3D SST, whereas for the Bay of Bengal the diurnal SST magnitude is peaking at around 4 degrees centigrade, whereas for the INSAT-3D SST it is 0.8 degrees centigrade. So we found the average diurnal variability of INSAT-3D SST is 0.87 degrees centigrade, whereas buoys have shown 0.54 degrees centigrade over the North Indian Ocean. Coming to the satellite comparison, INSAT-3D SST versus MODIS SST. This is the spatial correlation map of the for INSAT-3D versus MODIS SST. We have found very strong correlation of 0.86 and with a bias of minus 0.11 and RMSE of 0.06, and the table shows the mean and standard deviations of the MODIS and INSAT-3D SST. Here we have considered the MODIS Aqua Day SST and we have found very strong correlation. Coming to the overall summary as results and conclusion, we carried out day and night and regional validation of latest version of INSAT-3D SST against buoy SST over the North Indian Ocean. We have found daytime observations are relatively better in comparison with the nighttime SST, and skin and bulk SST differences has large variability in comparison with the buoy observations, and we have found very strong correlation of 0.86 compared to the previous versions of INSAT-3D SST. With previous versions of INSAT-3D SST data, we have carried out the validation of previous version of INSAT-3D SST from 2015 to 2017. Those results are explained in the paper Swapna et al. 2022. And in coming to the diurnal variability of this INSAT-3D SST, buoys are showing average diurnal variation of 0.57, whereas INSAT-3D SST is showing 0.86 degrees centigrade. So overall, the latest version of INSAT-3D SST, which was derived using 1D variational technique, show improvement in terms of RMSC, correlation coefficient, and well represented the diurnal variability in comparison with buoy SST. As this we confirmed, as I told in the previous study, we have got high RMSC and low correlation coefficient in comparison to the latest results. So the paper which I was telling you right now is that this is Swapna et al. 2022. If you refer this paper, you will find the detailed validation of previous version of INSAT-3D SST, and here I acknowledge the data provided at Indian Moored Buoy Network from INCOIS, NIOT and MOES, and INSAT-3D data from MOSDAC, and MODIS SST data from NASA NOAR greatly acknowledged, and I thank Director NRSC for his encouragement to carry out this work. This work is carried out as part of National Information System for Climate and Environment Studies, which is a nicest activity of NRSC ISRO. Thank you one and all. Thank you.